Let us now name polyatomic compounds. The very first thing to do when you are naming a compound is to identify whether it is type 1, type 2, or type 3. In all of the compounds that we have here, we have metals. So they can only be either type 1 or type 2. The question is, what type of metal? Let us begin with the first one. The metal here is potassium. If you look at the periodic table, you will see that potassium is from group 1A. All the elements in group 1A have a charge of +1. Since it has a specific charge, we do not need to put the charge in a parenthesis in front of the name of the metal. So we will simply name this compound like a type 1 compound, and that would be potassium phosphate. We named it phosphate because PO4 is phosphate. Let us move on to the next one. The metal in this next compound is nickel. If you look at the periodic table, nickel is a transition metal, which means we will need to figure out what charge it specifically carries. And to do that, we would begin from the polyatomic ion side. This is NO3. That is nitrate. Nitrates always have a charge of -1. Go and look at the polyatomic ions that we learned about. So if each nitrate is -1 and we have 3 nitrates, that will give us a total of -3. And to balance out the negative charges, that means nickel must have a charge of +3. So the name of this compound will become nickel 3 nitrate. Let us move on to the next one. Take a look at the first element in the compound. It is magnesium. Magnesium is from group 2A. It has a specific charge. Magnesium will always be +2. So we will simply name this as a type 1 compound, and that will be magnesium hydroxide, because the polyatomic ion is hydroxide. Let us move on to the next one. The first element in this compound is vanadium. It is a transition metal element. It has variable charges. So we would have to figure out the charge it carries in this compound. And that means we will need to begin with the polyatomic ion. The polyatomic ion here is chlorate. We have 3 of the chlorates, and each chlorate carries a charge of -1. which means the total negative will be -3. And that means the total positive will be +3, which means that the name of this compound should be vanadium 3-chlorate. Let us move on to the next one. We have silver as our first element. And silver is a transition metal. But silver always have one particular charge, and that is always +1. So, although silver is a transition metal, it will not be named like a transition metal. We would not need to place its charge in front of the name of the metal. So, this compound will simply have a name of silver carbonate. The polyatomic ion here is carbonate. Let us take a look at the last one on this list. And the first element in this is lead. Now, lead is not a transition metal. However, lead has two possible charges, +2 or +4, which means we will need to be specific about which type of charge lead is carrying in this compound. And to do that, we will need to begin with the polyatomic ion. The polyatomic ion is sulfate. Sulfate is always -2, which means that the lead in this compound would have a charge of +2 to balance out the -2. So the name of PbSO4 will be lead 2 sulfate. If you write lead sulfate, you will be wrong. Let us now look at how to write the formulas of polyatomic compounds from their names. Let us start with gold 3 nitrate. And this is very easy to do because we know that gold has a charge of +3 as given in the name. So we have gold with a charge of +3. The polyatomic ion here, nitrate, we know the formula. It is NO3 with a charge of -1. Which means to balance out the charges, I will need to have 2 more nitrates. So that the total negative will be -3 to balance out the total positive, which is +3. So the formula for gold 3 nitrate will be AuNO3 because we need 3 of the nitrates. Let us move on to the next one, strontium phosphite. Strontium is an element from group 2A of the periodic table. So strontium will always have a charge of +2. Phosphite is a polyatomic ion, and from the ITE that ends the name, it is known that it is a member of a family with few oxygen atoms. So, phosphite, if you remember from the polyatomic ions, will have a formula of PO3 with a charge of -3. We need to balance out the positive and the negative charges. So, we would need 2 more strontium and we will need 1 more phosphite. That ensures that the total negative is -6 and the total positive is +6, which means that the formula for strontium phosphite will be SR3 parenthesis PO3 2. If you write this formula without the parentheses around the polyatomic ion, you will be wrong. Let us take a look at molybdenum 6 sulfate. We have molybdenum with a charge of +6. And we have sulfate, which is a polyatomic ion, and the 8 is a giveaway. It means it is a member of a family with more oxygen atoms in it. So, from what we learned about sulfate, it should be SO4 with a charge of -2. To balance out the positive and the negative charges, I will need to have 2 more sulfates so that the total negative will be -6 and it will balance out the total positive, which is already +6. So the formula of molybdenum 6 sulfate will be MO SO4 3. Again, be mindful of the parentheses. What about osmium 5 hypobromite? Osmium, according to this name, has a charge of +5. So osmium with a charge of +5. Hypobromite is a polyatomic ion. The hypo means that it is a member of the family with the fewest oxygen in it. So, hypobromite will be Br with a charge of -1. To balance out the charges, I will need 5 hypobromite, so the formula will be OS BRO5. And lastly, the formula for ammonium carbonate. Both of them are polyatomic ions. Ammonium happens to be the only one among them that is positively charged. It is NH4 with a charge of +1. Carbonate, on the other hand, is CO3 with a charge of -2. To balance out the charges, we need 1 more ammonium ion so that the total positive is +2, and that will balance out the total negative, which is -2. So the formula will be 2 of the ammonium to 1 of the carbonate, and that would be the formula of ammonium carbonate.